Hello, we're going to be troubleshooting an issue, and the issue is our motor doesn't work, and when we walked out to the machine, there's three lights flashing. There's a jog light, a run light, and a power light all flashing, and the motor does not work. So that's our known condition, and to troubleshoot this, what we're going to do is we're going to figure out why these lights are flashing first of all, and hope that that leads us to the problem. So what we could do is, if we have the wiring diagram and we can see the lights are flashing and we know what the output is from the PLC, you can go over here to this data file and open up this output data file. And actually, if you look at this right here, where my cursor is, right here, here, and here, you can actually see in all three of those go from a 1 to a 0, 1 to a 0. And as I hover over it, you'll see this one's called the jog light, this one's called the power light, and this is a run light. So we can see, okay, there's what's going on. So what's causing those to flash is the next question. So if you do a right click over one of these and you do a cross reference, what you want to do is you want to look for the OTE, because the OTE, which is output energized, is what's causing this thing to flash in the program. So if we go here, you see there's our run light, and you'll see it's flashing on and off. And if you follow this rung back, all you need to do is look for the branch that's complete or highlighted. You'll see this first branch, this bit here is highlighted, but this one here is not. So this branch could not cause that run light to flash, nor could this one down here, because only half of the branch is complete. This one above it right here, you can see there's only one bit that needs to come on to turn that run light on and off. So this is what's causing it to happen. It says run light flashing for overload. Well, right off the bat, we probably found our problem. The fact that it's a motor overload, most likely. But go ahead and cross-reference this, because this B means it's a binary bit. It's not a real-world input or output. So let's really kind of see exactly what's causing that to flash. Again, right-click, cross-reference, go to the OTE. 90% of the time you're going to want to go right to this OTE, because that's what's controlling it. And you'll see, well, there we go, all three of these bits are flashing because our motor overload is tripped. And you can see that's input 3. So that's a real world input to the PLC. And I have the diagram, wiring diagram right here. And if you look at inputs on the PLC, input 3 is right here, motor overload. And it's the overload, normally open contact, that obviously closed to give us that input. And if I go back to the program, we'll know that that input is on right now because this bit is highlighted. That tells you that the PLC is seeing voltage at input 3 right now. So for it to see voltage at input 3, we know this is closed. Without even getting our meter, we can we know for certain it's closed because, oh, excuse me, up here, input 3, because it's on. And on our actual box, or training box, right here is the normally open contact that is now closed because of a tripped overload. So it's really important to understand, to go back from the program to the component and know exactly, okay, where is this contact, what is this overload trip, and exactly what does it mean. So hopefully this will help you in the future, not only troubleshoot PLC code, but understand where to find this overload contact on an Allen Bradley motor starter. Thank you.